Today we're going to work on 452. Let me give you a really quick review of trig. So we have the sine of theta, the cosine of theta, the tangent of theta. Sine is O over H, cosine is A over H, and tangent is O over A. You guys can remember SOHCAHTOA, right? Okay. Then connected with those are the cosecant of theta, which is H over O, the secant of theta, which is H over A, and the tangent, or sorry, cotangent of theta. Nope, try again. The cotangent of theta is O, yeah, my goodness. How about A over O? And the way I remember that, sine is attached to cosecant, and cosine is just attached to the regular the regular secant. So sine is attached to one with a co, and the cosine is attached to one without. Okay. If I had a right triangle and I had 5 and 20 degrees, how would I find x? Which trig ratio would I use? Sine. Because here's theta, that's O, that's H. So the sine of 20 is equal to 5 over x. Now this is a switch problem where the variable's on the bottom. So we just switch places with those. And I get 5 divided by, maybe, 5 divided by the sine of 20. Does everybody remember how to do those? Okay. What if I had this? 6, well, that'll work. That's fine. X, 15. Which one am I going to use here? Tangent. So the tangent of 15 is equal to x over 6. How do you solve that? You just multiply by 6. And you get 6 tangent of 15. Everybody's okay with that? All right. What if how would I find theta? Sine. So we know that the sine of theta is 7 over 9. But I don't want to know 7 over 9. I want to know theta. Take the inverse. Good job. Sine inverse allows me to switch those. 7 over 9 equals theta. Where do I find the sine inverse button? Second sine of 7 divided by 9. And I get 51 degrees. Okay, did everybody remember that? All right. So let's say I had a right triangle where I had a 5 here and a 6 here, and I wanted to find h. So that would be 25 plus, so a squared is 25, b squared is 36, equals h squared. So 25 and 36 is 61, equals h squared. So h is the square root of 61. Everybody remember that? So I'm just going to write the square root of 61. Let's call this angle theta. What does the sine of theta equal? Oh, it died. Dang it. Sorry. Sorry, I hope you wrote all those ratios down. So 5, 6, and root 61. The sine of this angle is 6 over the square root of 61. But I can't leave square roots in the denominator. Does anybody remember the trick? So root 61 over root 61, and the bottom just becomes 61. So it's 6 root 61 over 61. That's called rationalizing the denominator. And it's pretty easy to do. 5 over the square root of 2 turns into 5 root 2 over 2. 5 root 2 over 2. Okay, what if I had 10 over 2 root 3? What would I do there? It would be 10 root 3 over 6. And then those actually cancel, and I get 5 root 3 over 2. So you only have to change the irrational portion. Brance, you confused? Oh, sorry, I canceled it wrong. No wonder you're confused. So you're not confused. I'm confused. So this is just kind of the building blocks of what you need to do for today. And everything we're doing today should be review. Okay? No, it's in the book. So, and I think we have an okay grasp of radians, correct? So turn to page 452. And in the first set, we have this triangle. What is the length of the third side? It depends on the problem. Actually, hopefully you won't need your calculators today. So, I have 1 squared plus 2 squared equals c squared. So 1 squared is 1, 2 squared is 4. So c squared equals 5. So this is the square root of 5. And then you have a theta. So problem number 1, what is the cosine of theta? Oh, sorry. 1 over the square root of 5, which turns into root 5 over 5. Yep. Okay, what about number 3, the secant? Secant matches up with which ratio? Cosine. So secant is just the cosine flipped upside down. It would be h over a, which would be root 5 over 1. That's the secant. Yes, you only change... Oh, you can get rid of the 1. Yeah, but if there is a root in the bottom, you definitely need to switch it. Okay. The same thing happens in 7 through 12. You just need to find that missing side. All right, now, what about angles that are not attached to a triangle? Okay, like number 30. Oh, our assignment today, I might as well write it out, is going to be 452, 1 through 31, and then, no, it's going to be all. But then we're going to skip around a little bit. 35, so 35, 37. Okay. Let's do it this way. 1 through 30 all. And then 31 to 45 odd. That'll be good for today. All right. What if you don't have a triangle? So look at number 13. the sine of 30 degrees. You can, but you'll end up with the decimal. So 30 degrees. This is number 13. Well, remember in the unit circle, 30 degrees would be right here. And there are only 3 lengths in the unit circle. And in order from smallest to biggest is 1/2, root 2 over 2, and root 3 over 2. So in the unit circle, this is the short length right there. And then this is the medium length right there. And this is the long length right there. Okay, so you basically have 3 triangles that you need to worry about. You have this one, which is 30 degrees. And you have this one, which is 45 degrees. And then you have this one, which is 60 degrees. Can you guys remember that? Okay, so this must be 1. This is the long one. It's root 3 over 2 and root 3 over 2. And then in the 45 degree triangle, they're both root 2 over 2. Okay, and do they give us a unit circle? If they don't, I'll print you one out. Right, but I don't see a unit circle. It's 1 over root 2. So remember, in the unit circle, the radius of the circle is 1. And then our triangles are 1, root 3, and 2, or 1, 1, square root of 2. And we just change them. We have to rationalize them. So it ends up being root 3 over 2. Right? I divide these by 2. I divide these by root 2. So you'll get used to it again in just a second. Okay, so sine of 30 degrees. That is this triangle here. Okay, the sine is the opposite side divided by the hypotenuse. But in the unit circle, the hypotenuse is 1. So all we have to look at is the x length or the y length. Is sine going to be the x length or the y length? Is sine the opposite side or the adjacent side? It's opposite over hypotenuse, but hypotenuse is 1. So we don't need to worry about the 1. So how big is that length right there? 1/2. Okay. If I did the cosine of 45, how big is that length right there? Root 2 over 2. If I did the sine of 60 degrees, how big is this length right there? Root 3 over 2. Is that kind of coming back to you? So sine of theta is the y value, and cosine of theta is the x value. Okay. Oops. All right, so look at number 15, pi over 6. Well, 30 degrees is the same as pi over 6. 45 degrees is the same as pi over 4. And 60 degrees is the same as pi over 3. And I'm going to get you a unit circle. I didn't realize I was going to need one today. So 30 degrees is the same as pi over 6. So number 15 says, what is the cosine of pi over 6? So we go to this triangle, and cosine is x. How long is the ground? Root 3 over 2. Okay. And remember, it's root 3 over 2 divided by 1, which is just root 3 over 2. Okay. All right. 19, 20, and 21. So I'll do 20. Well, and probably 19. So remember, tangent is just the sine divided by the cosine. So if we go to pi over 4, which is going to be this triangle right here, what is the length of sine divided by the length of cosine? Nope, we're at 45 degrees. We're looking at this one. So it's root 2 over 2 divided by root 2 over 2, which is 1. Anything divided by itself is 1. Okay. What about number 19? 30 degrees. So 19 is this. It's 1/2 divided by root 3 over 2. So 1/2 divided by root 3 over 2. And then Corbin, what do? You flip and multiply 2 over root 3. Those cancel. And I get 1 over root 3. But 1 over root 3 is really root 3 over 3. Okay. So reciprocal identities. Number 22, how would you find the cosecant of 30? You take the sine of 30 and you flip it upside down. So what is the sine of 30? 1/2. So you flip that upside down and you get 2. Okay? And then 31 through 45, you're going to plug them in your calculator, but make sure you're in the right mode. To do the first half, you need to use, well, to do the radians, you need to use radians. To do the degrees, you need to use degrees. Where do I go to switch my mode? And it's the third or fourth one down, third one down. So you just make sure you know what version your calculator is using when you type it in. Okay, let me put a unit circle up on the board and then I'll go print you guys one. Good luck.